Right, now let's perform sign analysis on this guy using this method involving a table. So what we really want to do, first of all, I think, is break it up into factors as much as we can so each piece is super simple. So let's do this. So this, it's basically factored, except what? Well, the major difference, or the major thing we need to do, is the bottom. And that, thankfully, factors very simply. It's a very straightforward factorization, and it's a repeated expression like this. And I like the look of that straight out the gate because x plus 1 squared is always going to be positive, right? Or at least non-negative because of the square. Squaring any number, if the number is 0, it's 0, but if it's anything else, the square is always positive, which is going to make life very simple. So let's now draw a number line, which is where we're going to catalog the sign of the overall function. And then down the side here, let's write the factors. So what have we got? 3 to the x minus 3, we've got 4 minus x, and then we'll do x plus 1 squared. Next, let's mark all the positions of importance. So those are the positions where these things are 0 or undefined. 3 to the x, never 0, brilliant. X minus 3, of course, that's at 3. 4 minus x is 0 at 4. So we'll exaggerate the scale. X plus 1 is 0 and x is minus 1. So let's put that over here. So now what we're going to do is just go through each of these intervals and work out if you're positive or negative. So first of all, 3 to the x is positive everywhere. Fantastic, right? It doesn't really affect too much. X plus 3. Well, x plus 3 is negative on this side, and at 3 it switches to being positive, so it's positive after this. 4 minus x, it's the other way around. You're positive until you hit 4, and then you become negative. And finally, x plus 1 squared, it's a square, it's always positive. If there wasn't a square there, it would be more complicated, but it's always positive. So then all we've got to do is just look at the number of zeros, or sorry, the number of negatives in each of these columns, and that dictates everything. So if there's an odd number of negatives, because it's a product and quotient, overall you'll get a negative, and if there's an even number, overall you'll get a positive. First one, 3 pluses, 1 minus, it's an odd number of minuses, you're negative. Next, 3 pluses, 1 minus, overall you're minus. Next, 4 pluses, of course, you're plus. Finally, 3 pluses and 1 minus, overall you're minus. Okay, so this tells us everything basically. The only thing to be maybe a little bit careful of is whether or not these breakpoints are 0 or undefined. This point is 0 because it gives a 0 in the denominator. This point gives a 0 as well because it gives us a 0. No, sorry, it gives a 0 in the numerator. This point is 0 because it gives a 0 in the numerator as well, x minus 3, and the denominator is fine because putting a 3 into this doesn't make 0 anything silly. However, at minus 1, we've got a big problem. At minus 1, we'd be dividing through by 0. And here you're undefined. So kind of a mistake I see is some people say, oh, there's a minus here and a minus here, so I can just put them all together into one interval, like minus infinity to 3. That would be wrong, because at minus 1 you're not defined. So to kind of describe everything here, here's the conclusion. So we are negative on the intervals minus infinity to minus 1, union minus 1 to 3, union 4 to infinity. So that jump over minus 1 is necessary because you're not defined. And then, of course, you're positive. You are positive on what? Positive on, this is much simpler, it's just 3 to 4. And you're 0 at 3 and 4, and you are undefined at minus 1. Good example.